Following up on our discussion about aggregate operations in the aggregate, we're now going to talk about a special case of aggregate operations, which are the short-circuiting aggregate operations. As I mentioned before, they typically can terminate without processing everything. An aggregate operation may process all elements in a stream. A good example would be run-to-completion operations such as map. So map processes all of the elements in the input stream, unless, of course, an exception is thrown. Let's pretend, for sake of argument, that that doesn't happen for our discussions. You can have behaviors that throw exceptions, and they will be handled in the normal ways that exceptions are handled. If they're caught in the block in which they occur, and you can recover, then the exception is masked, which could be good. But if you cannot recover in the block in which they occur, then they will propagate out of the stream, and then they'll be handled in some enclosing scope. But if it propagates up and up and up and up to the edges of the runtime stack, and you end up falling off the run method with an exception, then that will terminate the program in Java. There's something called an unterminated exception handler that you can use just to sort of note the fact that an uncaught exception, or an uncaught exception handler, I guess it's called, you can have that there, sort of your last goodbye. You can say, unhandled exception, see you later. You can log it, but you need to make sure that your exceptions are handled somewhere. Or you need to make sure that you catch them during debugging. In contrast to run-to-completion operations, short-circuiting operations halt any further processing after their condition is satisfied. And there's a bunch of them. So one is something called TakeWhile. And this is an interesting intermediate operation that's a short-circuiting operation that's also requires history, and it returns a stream consisting of a subset of elements taken from the stream that match a particular predicate. So as long as the predicate is going to be true, then the elements in the stream will be taken, and as soon as the predicate fails, the stream will no longer be considered. It might sound a little bit like limit at first, if you remember, or filter. It may sound like filter at first, but filter is different from TakeWhile in that filter looks at every element in the stream and decides whether to let them go through or not, whereas TakeWhile will stop after it reaches something that doesn't satisfy the predicate. So it's a short-circuiting operation. There's also limit. We talked about that before. That's a short-circuiting intermediate operation that will cause the stream to stop after it hits a reduced size or after it hits its threshold, whatever its threshold could be. Think back to the Fibonacci example where we were stopping after the first 100 Fibonacci numbers were generated. And then there's a whole bunch of short-circuiting terminal operations like find first, find any match, all match, none match, and so on. And these, again, can finish before traversing all the elements in the underlying stream.